Hey everyone, my name is Sarup Barwani from Senso AI, and this series is called Answers by Senso, where we invite the best of the best in the Silicon Valley community to explain basic concepts around artificial intelligence and all of the concepts and buzzwords you may be hearing around. Today, I have the pleasure of inviting someone who I met over the last year through a number of hackathons I was doing in the Bay Area. VP of Developer Relations at LlamaIndex, a very popular tool amongst developers. And we have Laurie Voss with us today, and he's going to talk about RAG and what is RAG. So a lot of you are probably hearing this word around. Maybe some of you have implemented it and used a RAG system and don't know it. But today we're going to uncover the secrets of RAG and talk about tangible use cases. So Laurie, thank you for being here and really appreciate you being on Answers by Senso.
Hey, thanks for inviting me. I'm sure this is going to be a good time.
Yeah, absolutely. So, whenever I start these conversations, I always start with one question, and that is, what is RAG? Like, what are we talking about here? So, why don't, in your terms, just explain what the concept is? And I'll sort of break it down with you throughout the conversation to get down to like a first principles, what I think the broader community will grasp.
Sure. Um, so RAG is an acronym. It stands for Retrieval Augmented Generation. And I find it's most useful to just break down each one of those words when you're talking about the basics of what RAG is. So uh, the thing most people call AI these days is large language models, LLMs. And what they do is they generate text. That is their whole thing. You give them some text and they generate some more text that matches that text. So that is the generation in retrieval augmented generation. Um, and the way that we're augmenting generation is by giving our LLM additional context. So LLMs are trained on mountains of data, enormous quantities of stuff pulled from the web and YouTube and everywhere else. Um, but that is very general purpose knowledge. It's very um, generic. When you are trying to get an LLM to perform a specific task or answer questions about your data, uh, it's important that you give it your data so that it has it. Like it probably doesn't have like the internal information that you keep within your company. Uh, and if it did, it'd be kind of worrying, honestly. So you sort of hope that they don't. Um, so uh, the way that you do that is the retrieval part. So we are augmenting our generation by retrieving additional information. Uh, the reason we call it retrieval is because um, an LLM can deal with a certain amount of context at any one time. You can give them a certain amount of input that they can process at any one time. We call that a context window. And their context window is limited. They can do even the best LLMs can do about 1 million tokens worth of context at a time. Um, you can think of a token as being like a part of a word. So like there's some formula to convert from tokens to words, and I forget what it is exactly. It's like 2.2 or something. Um, but uh, the limitation of LLMs is that you have way more context than they do. Your company has, you know, hundreds of millions of tokens worth of data inside of it, and the LLM can only handle 1 million at a time. So if you want it to answer a question, you can't give it every piece of information that you have. One, because it won't fit, and two, because it would be very expensive. The LLMs charge you by the token. So what you want to do is you want to be selective, and that's where the retrieval part comes in. You specify that you want the most relevant context and just a relatively small part of it to go as part of the context when you give your question to the LLM for it to generate an answer. Um, and that's the core of retrieval augmented generation.
So
Um,
so well put. And just to like you mentioned something that stuck with me. So, this whole idea of a context window being limited. And please do explain what a context window is on this show. But also, like, talk about the other side of it, because I want to make sure that everybody grasps the fact that there's an LLM has a limited context window to input information, but what is the thing that we store long-term memory in, right? A vector database, right? So maybe equate that into, I've heard a lot of people compare that to short-term and long-term memory. So I'd love for you to dig into those concepts and how do they correlate? And then we'll go on to use cases right after, because I'd love to the audience to kind of like mesh this into something they're already using in the real world.
Absolutely. Um, so the key thing about retrieval augmented generation that a lot of people don't think about is that the retrieval can be anything. As long as you are retrieving data from somewhere, it's retrieval augmented generation. So if the thing that you do to give the context to your LLM is you run a SQL query, then it's retrieval augmented generation. If you are fetching a PDF from a pile of PDFs that you have on your hard drive, then it's still retrieval augmented generation. But there's one specific technique, as you pointed out, that people use all the time with retrieval augmented generation, which is vector databases. Um, so I should explain what a vector database is. Basically, um, you can take textual information and run it through what's known as an embedding model. It's a technology closely related to LLMs themselves. And what it does is it turns the text into numbers. Specifically, it turns it into arrays of numbers. And those arrays represent vectors, which is a very um, obscure mathematical concept, but you can think of it as like a point in space. So if you imagine like a 2D diagram, you've got, you can locate any point on your 2D diagram by saying where it is on X and Y. That would be a 2-point vector. If you added a third dimension and you were locating it inside of a cube, that would be a 3-point vector. Uh, the vectors used by embedding models have hundreds and hundreds of dimensions. They have like 700 dimensions on a regular basis. So you're embedding this data as points in these incredibly multidimensional mathematical spaces. Um, and what gets embedded when you encode your text into numbers is the meaning of that text as far as an LLM is concerned. And that is the magical feature of vector databases, because imagine you have a question that you want to answer, uh, that you want your LLM to be able to answer, and you have, 10 million tokens worth of data stored in your vector database. What you can do is you can take your question and run it through the same embedding model, and you can put it in vector space. And because your question is going to have the same, like it's going to mean the same thing as the answer to your question, inside of vector space, your question and your answer end up mathematically speaking nearby to each other. So you can do relatively simple math on the vector and say, okay, give me all of the points in space that are pretty close to my question. And that will form the context that will contain the answer to your question.
Amazing, amazing. Very well put. I do want to come back to how this is related to the context window, but before we go there, so we have a vector database, and the vector database thinks in many, many dimensions, and it's able to store vast amounts of information, meaning that we transform, text that we understand, that we humans understand, and we encode that into this multidimensional system so that a model can retrieve the right, uh, the right, um, the right associations in latent space, and that is push back to the other side, the model, and put into the context window, right? So talk a little bit about the context window now. Once information is retrieved and goes into the context window, then how does a model like GPT-5 take that and actually produce the elegant text we see in, you know, a customer support bot, for example?
So that is a complicated process. Um, the essentially what you are doing with any LLM is is um, you can model it as sort of autocomplete, right? You can think of it as a very, very fancy version of autocomplete. So you've given it a whole bunch of text and you've said, this text is your prompt, this text is your context. Um, Generate text that looks similar or looks appropriate to complete the text that I have given you. Um, the way that that works is it follows examples seen in the original text. So one of the things that people are used to LLMs doing is you ask it a question and it gives you an answer. Um, there's nothing specific in the training of LLMs that says, if I give you a question, you will give me an answer. It's just that usually in the corpus of all English language, when there's a question, the thing that follows it is an answer. Uh, so it says, okay, you've been talking for the last, 10 paragraphs of context that you gave me about, uh, I don't know, Uber's 10K report. Uh, and you've asked a question which is about that 10K report. I will use all of this context you've given me. I will use your question and I will generate a thing that looks like an answer to that question using that context.
So let's talk a little bit about, and one of the questions I get a lot in enterprise when I speak to individuals in the enterprise that are actually looking to implement a RAG system. The first question that I get usually is, well, when am I using RAG? Am I using RAG when I'm actually typing into ChatGPT and getting an answer? Or is RAG only used in a workflow where it is, maybe a customer support workflow where it's retrieving PDFs and everything. So maybe like separate those two things and break it down in terms of when is RAG used and when is RAG not used in each of those examples.
Sure. So again, uh, I think the public perception of RAG and the actual definition of RAG are at odds. Every time you are retrieving some subset of data that you've got that is smaller than your context window, you're doing RAG. So when you are asking a question of ChatGPT, it's usually just answering a question by using its training data. However, ChatGPT these days has a thing called memory. It remembers stuff that you've told it before, and that is absolutely rad. Um, it is, you know, OpenAI doesn't specify exactly how it's done, but we are relatively certain that they are using a vector database under the hood to retrieve the most relevant things from all of the stuff that you've ever told ChatGPT relevant to your question before it answers that question. There are also things like customer service bots, like you've said, where you feed them, for instance, your company's, operating manual or something like that. And when people ask a question of the chatbot, it fetches the most relevant pages from the operating manual and answers the question based on that. And that too is RAG.
Got it. Got it. Well put. Now, here's another question I get a lot, right? It's like a lot of people say, all right, well, you know what? I'm typing into ChatGPT, and yes, it has memory and, it's performing a RAG search based on my memory to give me a more relevant answer. And like, I always get the next question, which is, what is a prompt? Is the prompt the thing I type into ChatGPT or the chat window? And then I always like introduce this concept of a system prompt, right? And it's how a system
Mhm.
is stored and leverages that input to perform some sort of retrieval that's more personalized to maybe the model or you. Can you break down the concept of a system prompt as it's used in a RAG system relative to the query that the user enters, which is also often referred to as a prompt? And sometimes I think that these two get that clumped together as well.
Yeah, absolutely. I mean, a prompt a prompt by definition is any text that you give an LLM. So everything is a prompt. um, uh, the the user's query is the user prompt, and the system prompt is usually a substantial chunk of very um, carefully designed text that explains to the model what sort of questions it is expecting to be able to answer. So your system prompt doesn't contain the information that you've retrieved from RAG. Your system prompt contains an explanation of what kind of things this system is expected to answer, how it should answer it, guidelines about what not to do, that kind of stuff. Um, and then that system prompt is accompanied by the retrieved context and finally the user's question.
Got it. So you have three things in that particular example going into the context window. You have the user query, you have the system prompt, which is context, instructions, warnings, anything that the LLM needs to understand when, generating the output. And then you have what was retrieved from, the vector database. That could be your memory, it could be a bunch of PDFs. And those three things go into a context window. Now, why is a context
Mhm.
window so limited? And is it like short-term memory?
So, context window is uh, I'm not sure that I could tell you without being an LLM designer exactly why the context window is limited. The context window is as much information as the LLM can reasonably process and think about at one time in one shot. Um, so it is, yes, it is like short-term memory, I guess. Um, I tend to think in terms of LlamaIndex, where we think of short-term memory and long-term memory as different things. We think of them as different levels of context that we do different levels of retrieval on. Um, but yes, the shortest of short-term memory is the context window and everything that you can cram into it at one time.
Got it. So when those three pieces of information go into the context window, talk a little bit of what happens and try to let's talk about a customer service use case. Let's say
Mhm,
there's a chat bot that a customer, starts chatting with, and it has access to a number of documents, let's say PDFs, on how to resolve a login issue, for example.
mhm.
Right? Talk a little bit about the step by step. User enters, I need a login issue. That's the one piece of information that goes into the context window. Then what happens
Mhm.
next?
So um, if the user says, I'm having trouble logging in, um, the first thing that is likely to happen is the LLM will um, transcribe that into what it thinks is a good query to a vector database. So it won't just take the phrase "I am having a login issue" and turn and embed that, although that sometimes works. It will probably say something. It will turn it into keywords like login issue and then some synonyms to login like passwords and connection string and username and stuff like that. Uh, and it will send those to the embedding model. Uh, and then it will get those vectors back and it will do a mathematical search um, for vectors in the vector database nearby to those vectors. That will come back with pages from the user's manual in this case that are about your login. So that's not keyword matching, right? They're not just saying if it's got the word login, I will return pages that contain the word login. It is pages that are about logging into the system, whether or not they have that actual word on it. Um, and it will retrieve those pages and convert them to text and send them back as context to the LLM. It will then give that context plus the original question to the LLM again and say, given this information that you've got, come up with an answer to this question.
Amazing, amazing. Now, one of the things that a lot of people are concerned about with these probabilistic models is that they're non-deterministic, meaning that they're not going to return the same answer every time necessarily, right? And people often refer to
Mhm,
the problem as hallucinations. How am I going to put this thing in production if it hallucinates and it's unpredictable? And people just haven't gotten their heads around the fact that these systems are non-deterministic because we're so used to deterministic systems. So, talk a little bit about
mhm.
how LlamaIndex approaches how to really kind of like gain control of the context window. A lot of people are referring this to context engineering. A set of evals probably drive this as well in terms of ensuring that, hallucinations get less over time in a production environment.
That is an excellent question. Um, the it's before you talk about hallucinations, it's important to understand where hallucinations come from in the first place. So you were talking about probabilistic. Uh, that is how text is generated by an LLM. It is uh, it is generating the next most likely word over and over. Like I said, it was autocomplete. That's what it's doing. It's coming up with this next most likely word. That doesn't necessarily mean that the word that it comes up with is true. It just means that it looks like it fits there. So my example is always, if I give you the prompt, the cat sat on the, you are positive that the next word is going to be mat, because in all of the corpus of English language, that's usually the next word that comes. Um, but if I give you the corpus, Laurie's password to log in is, you're not going to have a particularly probable word to insert there, because you don't know what my password is. You're just going to come up with a likely looking password, 1234556, for instance, which is, the most common password in the world. Uh, and that's a hallucination. It is the model trying to come up with something that looks like it fits when it doesn't have the information that would actually go there. So one of the best ways to avoid hallucination is to make sure that the model does have the information that would go there. So that is where RAG comes in. RAG is an attempt to make sure that it has the information in advance that would answer the question that it's being given. The ways that you so just by using RAG in the first place, you're reducing hallucination because you're reducing the chance that you will ask the model to generate a piece of information it doesn't have. Um, but then we get into context engineering, um, which is making sure that the full prompt, so the system prompt, the user query, and the context all together, uh, is the least likely to produce a hallucination. So part of that is just putting into the system prompt that the uh, that the LLM should use only the information it's just being given and not its training data to try and answer the question. That's a specific instruction that you can give the LLM that is remarkably efficient at reducing hallucinations, saying, don't make this up if you don't know, just in those words. Um, uh, and you also have to make sure that you're not giving it either too little or too much context, right? So you could retrieve one paragraph from your page on logging in, but that might not have enough information to answer the question. So you might give it the entire page plus the page before and the page after to see if that contains all of the information. And that's probably a pretty good guess, but you don't want to give it 10 pages before and 10 pages after, because then there's so much context that it's going to get distracted by things that are unrelated to your question. So context engineering is this very fluffy process at the moment. It is more art than science of making sure that your prompt is strict but not too strict, that your context is large enough but not too large and not too small, and that your query has been adequately translated into something that the LLM is going to give a good answer to.
Amazing. And I imagine there's ways we can measure this by version controlling prompts and really kind of measuring, A/B testing and kind of saying, hey, was this prompt better than this prompt? And basically iterating over time. That's certainly something we do internally at Senso on an ongoing basis to really kind of like just get closer to a better outcome every single day. So I imagine LlamaIndex also makes it very easy for enterprises to really kind of like just get started with that.
Yes, we have a lot of what you're talking about is evaluations. We have a lot of integrations with third-party partners about putting together integrations, um, and putting together an evaluation rather. An evaluation is just a set of questions and answers with um, you know true or false next to them, basically, or scores next to them, saying how good an answer was this. Um, the the gold standard for evaluations is always human generated. So a human got asked the question and a human answered the question, and you give the LLM a bunch of tries with the same questions, and you judge whether or not the answer that the LLM came up with is close enough to the answer an actual human came up with. Of course, in practice, that's an incredibly labor-intensive task. So what a lot of people do is a process known as LLM as a judge. So instead of manually or getting a bunch of humans to compare the answers that the LLM is coming up with to your gold standard human generated answers, you get a different LLM to look at these two pieces of text, the human generated answer and the LLM generated answer, and say, does this answer look like the human answer? Do they look similar enough? Is it correct? Uh, and in that way, you can do it very, very quickly. So you lose some accuracy because it's an LLM and the LLM itself could hallucinate. Um, but in general, what you get is uh, the ability to run over and over every time you make any change to the system, a bunch of tests, hundreds of tests or thousands of tests um, that tell you whether or not uh, your system is hallucinating or whether it's giving good answers.
Right. And I imagine that like this is like varies task to task. Like for example, for something like code generation, because you have a constant verifiable feedback loop, you're able to improve much faster or much more elegantly and deterministically than something like writing, which is often subjective.
Absolutely.
Got it. Um, so let's talk a little bit about, just to wrap it up, let's talk a little bit about the future of RAG. This thing is evolving so fast. Like, every other day we're seeing like new breakthroughs and everything. And a lot of people are saying like, you see like Twitter hype, right? RAG is dead. Do you believe RAG is dead, or do you believe that RAG is the future?
I think there's just no way that you can uh, get around the fundamental limitation of LLMs without using RAG. The fundamental limitation of LLMs is that they don't have your data. You have to give them your data. Um, as long as you're doing that, as long as you're giving them data that they didn't have before, then you're doing RAG. And unless you want to, train your own large language model on all of your data every single time, which would be extremely slow and prohibitively expensive, uh, you're always going to want to do something that equates to RAG, whether or not it's always going to use a vector database, or whether or not we're going to come up with some other technique to get more relevant information out of large databases. That can evolve, I think. But uh, the base technique that you are, retrieving some information and using it to augment your generation is going to stick around.
Got it. Now, just for fun, just to play devil's advocate, Sundar constantly claims that we're going to have infinite context windows. So, if you had infinite context windows, why do you need RAG?
If you had infinite context windows, then the reason you need RAG is because it would cost you infinity money, right? Like if you have, like I said, you have tens or hundreds of millions worth of tokens of context at your company. If your solution to answering every question is to give it 100 million tokens worth of context every time, then that'll work, but it'll cost you, hundreds of millions of dollars. So being more specific is always going to be the cheaper and more efficient route.
Awesome. No, that's fantastic. And, for everybody in the enterprise, there are always trade-offs to the models you use and the various factors that play into whatever workflow you're implementing this in. And Laurie just pointed out an amazing one, which is, cost versus efficiency versus like many other factors that play into. Talk a little bit about some of the trade-offs, Laurie, that you see on a day-to-day basis when you're working with like enterprise customers or even like with some of the model providers.
I think latency is one of the biggest trade-offs that enterprise customers deal with because um, there's a pretty, I'm not going to say linear because a mathematician will correct me, but like there's a pretty direct relationship between how long you give an LLM to think and how good the answer gets to be. One of the things that we do a lot of the time at LlamaIndex is we build agents. Um, RAG is, fundamental to answering questions about data, but one-shot RAG is very naive. You can do a lot better by building an agent that can think about the question it's being asked. It can ask the RAG database multiple different questions. It can put together those different answers with different questions all together and come up with a cohesive answer to a complicated multi-part question that RAG by itself would be bad at doing. Because RAG is very much a form of search, right? It's looking for a specific question and answer. If your question is compare A and B, uh, then RAG is going to do a bad job because it's going to look for a piece of text that is about comparing A and B, which is not what you wanted. What you wanted was tell me about A, tell me about B, and then get the LLM to do the comparison. And that kind of, that's a very simplified example, but that kind of additional thought and additional um, effort is where agents really shine. They can think about the question they've been asked. They can decompose it into multiple questions. They can refer to external tools for data, not just the RAG database. They can do all sorts of stuff. Um, so uh, using agents in that way is a really great way of improving the quality of the results you get. But the more things your agent does, the longer your response takes. The more thinking it does, the more tool calls it makes, the more round trips to the RAG database it has to make. Um, so a lot of what we are doing in an enterprise context is balancing how quick is this answer, how quickly do you need this response, versus how deeply can we think about it.
Awesome. Last question about the topic, and then I have one final question I ask every guest. But the word agent has almost become a buzzword in the enterprise. It's one of those words right now where everybody hears it and like it's lost all meaning, right? So I always ask every
Mhm.
guest at this point in time, like, what is an agent to you? Like, define what an agent actually is.
Um, I consider an agent, by a fairly loose definition, and I consider an agent an LLM that has access to tools and is given a goal rather than a specific instruction. Um, so you can imagine um, a customer service agent, like an actual agent, um, instead of just giving it, just being a RAG bot that says, okay, I will look at this specific database and I will find the most relevant context and I will give it back to you with the answer. You could give it multiple databases. You could say, here's our customer service database. Here is our order tracking database. Here is, a database of the weather in case they ask a question about the weather. Um, and an agent is able to decide between those three databases which one is the most relevant one to query. And that is the fundamental nature of an agent, is it is making decisions and not just giving the fastest possible answer. But you can give agents all sorts of tools, right? You can give them tools that don't just retrieve information, you can give them tools that take action. So the agent can, not just tell you the status of your order, it can cancel your order, it can create a new order for you if you give your agent that ability. Um, and so agents are a significantly more flexible uh, beast. They're a much more powerful piece of software than just a RAG system would be.
Perfect. And, agents need to be monitored and observed. There's a lot of observability that comes out of this, and Llama Index provides a lot of that. Just to kind of like wrap up, I'd love for you to talk a little bit about Llama Index and like how anyone that's looking to kind of implement a RAG system in enterprise or any of the tools that you offer, whether it's observability or evaluations, can really kind of get in touch and speak with you about that.
Sure, we are at LlamaIndex.ai. Um, and we are both an open source framework and an enterprise service. So if you are, interested in rolling your own system, you can do it from the open source. But if what you want to do is get uh, world-class RAG out of the box, that is a service that we provide called Llama Cloud. There are various other parts to it, including uh, our sort of um, uh, our flagship service, which is called Llama Parse, one of the things that we have learned from implementing, thousands and thousands of RAG systems is that the quality of the answers you get is related not just to the quality of the data you put in, but how efficiently that data is parsed, how well that data is translated into a form that LLMs find easy to understand. So Llama Parse is the result of uh, hundreds of thousands of person hours of work into making the best possible parser for LLM-based applications, and we're very proud of it.
Amazing. It's an incredible, incredible platform. Laurie, thank you so much for always being so kind and for joining me today. I have one final question, and this is nothing to do with RAG, but we all stand on the shoulders of giants to be where we are today, witnessing what I think is one of the most important moments in human history. I have four pictures behind us. On the top, you have Steve Jobs, and then you have Alan Turing, and on the bottom you have Nikola Tesla and Johannes Gutenberg, right? Four individuals that I think had a lot to do with where we are today, and just sparking this AI revolution. The printing press, electricity, the computer itself, the mobile phone, right? And so, talk to me a little bit about which one of these stand out to you as like a hero. And if it's not one of these, feel free to bring one of your own into the picture. It doesn't have to be one in here, but like let's pay homage to the greats of the past.
I was looking at the picture of Turing from the moment we started this conversation. Turing is definitely my favorite. Um, he he helped win World War II and all of the things that people already know about Alan Turing. But as a member of the LGBTQ community, the fact that he was also has always been very inspiring to me. That one of the founders of the industry uh, was one of us is always been inspiring to me.
Yeah, and back then it wasn't as easy, right? And so he broke down barriers.
No, it was incredibly difficult, and if you go into the history, it's pretty horrible what the UK government did to him. But we I try to focus on the positive there.
Of course, of course. Laurie, awesome having you on. Thank you so much and explaining to our community what RAG is all about. Appreciate it
Thank you so much for having me on.
for sure.